In the last video, we discussed the overall problem formulation process, especially from an analytics perspective. In this video, we will look into statistics specifically as a subset of analytics, and we'll look into the discussion of the role of statistics in data-driven decision making, and we'll also formulate a certain way of hypothesizing within statistics, which is going to be a little bit different from what we did in the previous video. So first and foremost, we would start off with the definition of statistics, and I have reviewed this briefly on my 18th class, but I want to reiterate it because it is such a loaded sentence here. So let's go over this real quick. It's an area of science concerned with the extraction of information from numerical data and its use in making interfaces or inferences about the source from which the data is obtained. So let's break this up into parts. First, it's an area of science, so it's a scientific approach to managing data. The scientific approach essentially meaning that it's an approach that deals with a problem, formulates it, solves it, communicates it. That's a scientific approach to management. Concerned with the extraction of information from numerical data. So in essence, you are looking at a transformation process from data to information. Now, this can turn out to be mind-boggling for some of you because in the regular way of speaking and writing, we oftentimes use the terms data and information interchangeably. The reality is there is a big difference. Data is just a bunch of numbers that has no significance, that is not something that you will use to frame your decisions. When you are eventually able to convert that data, manage it, to be able to make informed decisions out of it, then it becomes information. So that is the journey that statistics helps with, converting data into information. So that's the first step. It's the extraction of information from numerical data and its use in making inferences. Inferences is essentially where you actually make that decision about the source from which the data is obtained. So if you look back into the example that we discussed in the previous video, I had data from 73 nations, if you recall. But 73 nations here represent my entire world. So the world here is the population. The 73 nations here is a small sample out of that population. So at the end of the day, I am analyzing this sample data. But the inference that I am making, the decision that I am making is going to apply to this entire world, which is the source of this data. And that's the whole essence of statistics, to be able to use a subset, a small number of data points to make inference and decisions about a greater population from where those data points are coming. That's essentially what statistics is about. So with that backdrop, let's look into the same problem-solving approach that we discussed in video 1, only in the context of statistics here. Okay, so when we talk about data-driven decision-making, in essence, this is what we are looking at. We start off with the problem definition. It is always the first piece of the puzzle, right? Because the buck starts there. This is no different than everything that we have discussed in the previous video. How do you define the problem? And when you define the problem, you also hypothesize based off of that problem. You frame your opinions. You take a stance. you have a certain belief of an outcome. Whether that belief actually makes sense or not depends on how you analyze the data that you gather based off of your model or the conceptual model. So that's where you start looking into gathering data. And this is where the idea of a population, a sample, and all of that comes. And we will discuss all of these in detail throughout this class. This video is about giving you an overview of the data-driven decision-making process as it applies to statistics. So the first and foremost step is your data available? If the data is available, then you pick a small sample out of the large availability of data, very similar to what we did in the previous video. We have all of these countries available. We chose 73 nations. Sometimes there is no data available. You have to create your own data. This is where surveys and all of those measures come into place. Okay, so either you create a data set or you glean a subset of the original population. Okay, so either of those can work as your sample. But for either case, you have to ensure that the data is generalizable, that the data is projectable. And we'll talk about these in much more detail in a couple of videos later. But this is extremely critical because if your sample is not a good sample, all of the analysis that you do doesn't make any sense, because eventually you are going to make decisions about the underlying population based off of that sample. And if that sample is not accurate enough, then the decisions that you make on the population are also equally inaccurate. And so a lot of care needs to be taken in designing that sample. But once that sample has been designed, the next step is to organize and summarize data. This is where you look into visualization of data, trying to get a meaning of what the data is trying to say. Again, you are not concluding anything at this point of time. It gives you what I call a smell test of how the data might behave. And that is extremely important. It also allows you to communicate a lot of initial ideas with people who have no understanding of statistics or data analytics, but they can look at a picture which is worth 1,000 words and get some meaning out of that data. What is the data trying to say? And then eventually, once that smell test is taken into consideration, you put that into an actual test where you want to analyze the data and you want to decide with confidence. So recall, we had discussed this on the 18th, that there are two broad reasons for us to pursue statistics. One is the fact that we have natural variability in our data. So we should be able to capture that variability and try and reduce that. And the second one is the difference between an opinion and a decision. And the biggest difference is in terms of confidence. When you are going with your hypothesis, when you are going with your belief or the stance that you have taken, how confident are you? And that is what statistics helps you establish. And based off of that, you infer on the problem and infer back to your hypothesis. So this is no different than what we expressed in our first video. The formulation of the problem, followed by the solving of the problem, followed by the communication of the problem back to your base. And that, in essence, is the structure of data-driven decision-making when it comes to statistical data-driven decision-making. Talking about hypothesis, if you recall from the video 1, the hypothesis that we made were very intuitive, right? So power distance versus deaths per 100K population. What would that impact be? What would that relationship be? What would that association be? And there is a lot of gray area in that process. And that is, again, a very correct hypothesis. But from a statistical sense, what we look at is something more specific. So from a statistical sense, let's say that we are defining the problem that says, are baseball players overweight? We are trying to address that problem. And so when you are trying to analytically frame the aforementioned problem, the first question you ask yourself is, what does overweight mean? Who defines overweight? What is a threshold of when something is overweight? As long as you have that definition in place, everything else will fall into place. So in my definition, if overweight means, let's say, 180 pounds, if that is a definition of overweight for a game like baseball, and this is again me, the analyst, then suddenly an analytical way of framing the aforementioned is that on an average, so as long as average weight is greater than 180 or equal to 180, in other words, if a certain player is 180 pounds or over, then you call that the player is overweight. That's your hypothesis. When is the player okay? When the player is on the other side of the spectrum, which is average weight being less than 180. And again, we'll discuss this in much more detail from a statistical standpoint much later in this class. But this is the perfect time for us to at least get that understanding of what we're hypothesizing, because this has nothing to do with collecting data. This has nothing to do with analyzing the data. This is more about understanding the market, understanding how you want to conceptualize your problem. So again, one more time, are baseball players overweight? That's a linguistic way of saying that. From a statistical analytical standpoint, you want to define a threshold for that definition of overweight. And once you define that threshold, you can very clearly frame your hypothesis based off of that. Also note that because it is an analytic process, we are suddenly looking into a black and white scheme. Black and white scheme meaning it is a yes versus a no. You either go one way or the other, the yin and the yang. So either you're overweight or you're not. It's a very simplistic form of pursuing a certain belief and then checking whether your belief is met or whether it is not met. So if you recall, on the 18th, when we were talking about data-driven decision making, we looked into multiple scenarios. Let's review some of those scenarios and see how we can frame hypotheses around those scenarios if we take them as problem statements. Okay, so the first one was government elections, right? So the problem question or the statement that you may have is for a certain party, whether a party will win election or not. Okay, so you are essentially saying win versus loss, right? And so therefore the question becomes, from an analytical standpoint, what constitutes win? So as long as there is, let's say, 51% of votes cast for a certain party, that party can consider itself a win, right? So suddenly then you can define your hypothesis to be greater than equal to 51%, meaning a win, or loss in a different scenario. The US success or failure in the Middle East. So again, when you are defining success versus failure, there are so many different nodes around which you can define that. What about, let's say, success in the Middle East is being measured by the number of US personnel who are dying in the battlefield. Let's put a threshold to that number and say it, as long as only a certain number of people are losing their lives in the battlefield, we can call it a success. Anytime that number exceeds a certain value, then you are saying, we have failed in our mission. Many of us know that drones have widely been used in these proxy battles, especially in the Middle East. But drones are tremendously dependent on intelligence. And oftentimes what happens is a drone will strike a, an assumed terrorist location, but sometimes it will be a civilian location. So it will be a misfire. So maybe success can be defined by the number of correct hits by a drone as opposed to the number of misfires. Again, as long as you have that threshold in place, you are able to define your hypothesis off of that angle. Seventh generation, successfully positioning its products on Walmart shelves. So as we discussed on the 18th, when you're talking about seventh generation deciding how they set up the shelf positioning between multiple stores, what the height of the shelves ought to be corresponding to the eye level, um, what the angle of the product ought to be so that uh, customer sees a certain side of the product, and so on and so forth. At the end of the day, the success is measured by your sales. So if this is store one and this is store two, in essence, you are trying to look at the difference in sales from store one and sales in store two. And you are saying, as long as my sales increase by a certain dollar value, and that becomes your threshold, as long as my sales increase by a certain dollar value, because of my positioning of products, I'll know that the positioning process is a success. Successful positioning only happens when you see positive change in dollar figures in terms of sales based off of those positioning. So at what point would you consider it a success? Is there a statistical difference between those cells, between those two stores? If it is statistically different, then you will be able to say that yes, by positioning or repositioning my products on the shelf, I have able to be able to create a sales generation that is distinct from the other one in which the positioning is different. Why should I invest in Apple's stocks? And again, that investment policy, that investment approach can come from a multitude of angles, how you want to address that problem. Apple currently runs for a certain price. Apple has its own beta. Um, when you eventually take a course in finance, and for those of you who have already been in a finance class in your undergraduate, you have probably come across this term beta, which essentially defines what we call the volatility of a stock. Okay, in other words, how is the return of a stock performing corresponding to a standard? And the standard in most cases is the S&P 500, let's say, or the Dow Jones Industrial Average. And so when you are making those comparisons, you would be asking the question, how volatile is my stock? Okay, how is it moving against a standard? And how much of that movement can you live with? Okay, so this is where your risk averseness comes into play, and each one of you may be different. And that will dictate for you whether you want to put your money on a certain stock or not. Okay, so again, that beta here, then depending on that beta and your risk averseness, you will define your threshold, and you'll say, as long as the threshold of that specific number is reached, or is it less than that number, I will invest, and if not, I won't go for it. So this is how decisions are made around us on an everyday basis. We frame a hypothesis, then we run the data, and we see whether our belief or your expectations or our stance is met or not. And that is the whole idea of working with statistics. And we will get into much gory details on hypothesis testing much later in the class. but this is just a starting point for you. In the next video, we will discuss specifically looking into the population, looking into the sample, and we'll look into how you tabulate data based off of timing. It's a very interesting process that will dictate the way we look into data collection. And so chime in for the next video.